So, you want to be an electrical engineer. After all, using electronics to engineer the world of the future is pretty badass. Let's debunk the public myths of what it means to be an electrical engineer and give it to you straight. This is the reality of electrical engineering. To start, you might be asking yourself, what even is electrical engineering? To answer that, electrical engineering is the fuel that electrifies innovation, sparking breakthroughs in the seemingly magical devices of today. It's an essential profession on every project, from the James Webb Space Telescope to PlayStations and popcorn machines. You can find these engineers applying their math, physics, and computer science skills to develop intricate electrical highways known as printed circuit boards. These circuit boards route electrical signals to and from electrical components to accomplish everything from a mundane computer startup to controlling the sheer power and precision of a rocket's ascension out of Earth's atmosphere. Electrical engineers are the engineering jack of all trades as they utilize programming, hardware, and physical properties in their work, whereas other professions tend to mostly stick to one. No matter which way you look at it, electrical engineering is an exciting, lucrative field with tons of niche subfields to explore. But before we dive into the details, we'll explore the day-to-day responsibilities that all electrical engineers share. Particle accelerators, rockets, smartphones, and modern electric vehicles were all meticulously designed with hundreds of millions of basic electrical building blocks that every electrical engineer must know: resistors, capacitors, inductors, diodes, and transistors. As you can imagine, completing every single connection for that many components is not the work of just one engineer. To streamline collaboration, electrical engineers use a standard documentation scheme known as electrical schematics. A schematic is a visual representation of every single connection on a circuit. Electrical engineers must be very comfortable using them if they ever intend to get anything done. Trying to communicate a circuit without a schematic would be like trying to explain how each and every highway connects across the western United States. Obviously, you need a drawing to get the point across. Once a schematic is made and electrical engineers get their physical designs, they must measure and test them to validate their work. All electrical engineers work with lab equipment specifically designed to generate and quantify electrical signals. For example, an electrical engineer will use a tool known as a signal generator to introduce an electrical signal to their circuit board. The board layout herds the signal throughout the circuit, like water naturally flowing down the banks of a river. The components in the circuit respond to the signal and change its characteristics, like an amplifier component boosting the signal to be 10 times stronger. But how will our engineer know if the amplifier worked? They can view this amplification by connecting the board to a different lab tool known as an oscilloscope. This is a key piece of equipment in any EES lab setup that allows the engineer to see what is actually going on in the circuit, allowing them to see if the amplifier worked or not. There are tons of other pieces of lab equipment that electrical engineers must know about to test electrical designs. But we'll save that discussion for another day. Now that you have an idea of the responsibilities of electrical engineers, we can transition into a view of the most sought-after subfields that build on these important duties. We'll start with power systems engineers, or power engineers. These engineers are dedicated to the generation, transmission, and distribution of electrical power. They accomplish this by designing, operating, and maintaining electrical power systems. You can find a power engineer spearheading the design of a national power grid that supplies energy to every corner of a nation. On a smaller but just as cool scale, you can find these engineers designing motors that convert electrical energy into another form of energy. This can turn an axle and drive the wheels on the newest Tesla model, or ignite an electric plasma motor for jet acceleration. You can also find power engineers enhancing our world by finding creative new ways to harness the power of natural energy from the ocean, sun, and wind. So if you find yourself interested in revolutionizing the world's usage of electrical power on a small, national, or global scale, power engineering could be the right path for you. Now we'll explore telecommunications engineering, or more specifically, radio frequency and microwave engineering. And to answer your question, microwave engineers do not design microwave ovens. Radio frequency and microwave engineers use very high frequency circuits and electromagnetic waves of energy to transfer messages. These engineers are in demand across various industries, such as aerospace, defense, medical devices, and consumer electronics. RF and microwave engineers can be found figuring out the best way to securely encode a signal for transmission and implementing the circuitry to do so. For example, a radio station takes the audio signal that is your favorite Katy Perry song and modulates it, meaning that it is encoded as a high frequency and ready to travel through the air. It is then received and demodulated by the radio in your bedroom so that you and your pissed off neighbors can hear it nice and clearly. These engineers can also be found assisting the medical field, for example with MRI machines. An MRI uses radio frequency pulses and magnetic fields to generate detailed images of the internal structures of the body, giving medical professionals invaluable insight on their patients. So if you're interested in electromagnetic waves zooming through space or enhancing the lives of countless medical patients, RF and microwave engineering could be the profession for you. Next, we take a deeper look at signal processing engineers. Signal processing engineers create electronics and algorithms that analyze, manipulate, and interpret signals to extract useful information and maximize the efficiency of electrical devices and systems. These engineers are very knowledgeable in data manipulating mathematics and programming insanely efficient algorithms. A perfect example is found at the core of the newest Apple augmented reality headset. Signal processing engineers first create an algorithm that takes in all the data from the headset's various cameras and sensors. It is then able to quickly recognize, say, a pair of eyes darting to a widget on the home screen. Then, like magic, the algorithm instantly highlights the widget in sight, ready for the user to click on it at a moment's notice. As you can imagine, these engineers are also in very high demand, as nearly all systems and products of today require data manipulation of electrical signals to perform properly. So, if you have a good mathematical foundation, understand what it takes to efficiently accomplish a goal, and want to engineer the mind-boggling devices of the future, you might consider becoming a signal processing engineer. Alright, now that you have a general idea of what electrical engineers do, and have insight on a few of the most popular subfields, we're ready to take you into the enticing and not so enticing aspects of electrical engineering. To kick off the ugly side of electrical engineering, we look at the abstract, confusing nature of the profession. All of the exciting designs we've discussed so far in this video work by electric and magnetic fields moving energy around, which is invisible to the naked eye and extremely tough for the human brain to comprehend. It takes an especially imaginative and determined individual to successfully overcome this abstraction hurdle, which deters most people. Further, electrical engineers typically go through a lot of programming in their upbringings, which, alongside all of the circuit work, means that they have to deal with software and hardware, instead of just picking a lane like other engineering professions. Another con to electrical engineering is the never-ending technical obsolescence. You could have been the industry genius that pioneered the invention known as the flip phone, but a few short years later find yourself submitting your dust-covered design to a local museum for ancient artifacts. In this field, the desire for smaller, faster, and more efficient technology never ends, which can be a tiring endeavor for anyone. But if you are an imaginative, abstract thinker that enjoys the subject and welcomes the evolutionary nature of technology, all of these downsides suddenly turn into upsides. Moving into the exciting parts of electrical engineering, we remember that it's a very broad profession with tons of subfields. This vast applicability to many niches corresponds to a high demand and excellent career stability for electrical engineers. Further, society continues to trend toward more reliance on electrical devices, making the outlook for these engineers even more fruitful. And another bonus, they typically get to work hybrid remote. Seeing as most electrical engineers get to develop software, and this is obviously done on a computer, they can work comfortably from their own home, or wherever else they can code productively. And if that wasn't enough for you, electrical engineers get paid exceptionally well, even more than most other engineering professions. The crazy technical and abstract nature of the profession, mixed with the dense population of subfields, is a recipe for financial success. They also spend their entire career finding better ways to get the job done, making themselves ever more valuable and, in turn, wealthy. So, if you could see yourself enjoying the technical side of electrical engineering and want a well-paying, stable job with great benefits, we think you should take a serious look at becoming an electrical engineer. So, do you want to become an electrical engineer? Why or why not? Let us know in the comments. If you think you have what it takes to become an engineer, watch this video to find out just how right or wrong you are. Thanks for watching.